In this video, we will discuss about function-based Pascal triangle using RAPTOR. I'm Dr. P. Visena from CBIT. So this Pascal triangle formula, x plus y whole to the power of n is equal to nc0, x to the power of n, y to the power of 0, nc1, x to the power of n minus 1, y to the power of 1. The r term becomes to ncr, x to the power of r, y to the power of n minus r. The last term is ncn, x to the power of 0, y to the power of n. So in this equation, totally we have n plus 1 terms. So the rth term becomes to ncr, x to the power of r, y to the power of n minus r. So already you know the simple mathematics, 0 factorial is 1, 1 factorial is 1. So 2 factorial is 2 into 1. Similarly, n factorial is equal to n into n minus 1 into n minus 2 into up to so on to into 1. So already you know that this mathematics is the backbone for this computer science. So these are the required mathematical background. After that one, you need to think about the space adjustment in this Pascal triangle. So here you know the simple formula NCR is equal to n factorial by r factorial into n minus r factorial. So the simple factor, this is the simple mathematical representation. In order to make it programming, in case you need to write fact of n divided by fact of r into fact of n minus r. I'm calling this fact function by changing the parameters. First time n, next time is r, next time is n minus r. So reusability, I'm defining fact function only once. I'm using 3 times by passing the different arguments. First time is n, second time is r, third time is n minus r. Suppose if I'm passing my n value is 5, then you are getting the Pascal triangle like 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 5 rows, 1, 4, 6, 4, 1. So x plus y whole to the power of 4 is equal to x to the power of 4. So 4x cube y plus 6x square y square plus 4x y cube plus y to the power of 4. Now we are considering the coefficients only. So x to the power of 4, the coefficient is 1. So the second x cube y, the coefficient is 4. X square y square, the coefficient is 6. So x y cube, the coefficient is 4. Y to the power of 4, the coefficient becomes to 1. So now in this we are using input output symbol and processing symbol. Including this one, we are using this loop. Outer for loop will indicates the rows and inner for loop will indicates these columns. So now this basic algorithms we are using here, it is I need this. So 0C0 in first row, 1C1, 1C0, 1C0, 1C1 in second row, next 2C0, 2C1, 2C2 in third row, 3C0, 3C1, 3C2 and 3C3 in third row. Here 1C1 actually mistake. So the function based Pascal triangle algorithm, the outer for loop for I in range of n. So this will controls the number of rows in the triangle. So the outer for loop will represents these rows. So for this outer for loop, I am using this I loop. So representing these rows. So the inner for loop, J loop will computes each element of the row using the formula of binomial coefficients. So here in order to calculate this binomial coefficients, I am using NCR formula. NCR is evaluate NCR is equal to n factorial by r factorial into n minus r factorial. So this is simple mathematics formula. So already you know that mathematics is the backbone for computer science. So we can write it equivalent to program is fact of n divided by fact of r into fact of n minus r. So you need to apply the BODMAS according to your requirement. So for each row and column, we need to evaluate this NCR formula. So first is 0C0, 0 factorial is 1, 1 factorial is 1, 1C0, 1C1, 2C0, 2C1, 2C2. So after this one, you need to adjust your space adjustment using one K loop, K inner loop within the outer for loop. So this is my function-based Pascal triangle using RAPTOR. First, I am reading n value. So I am using this outer for loop, which is I loop, which is initialized to 0 I value. So I is greater than n, j is, next I am using inner for loop, j is 0, j is greater than I. So I am calling this factorial function by passing I, comma, res. So this I is the input parameter, res is the output parameters. So this I will represent the rows, that is 0. Here I value becomes to initially 0. So 0 factorial value will be written here, it is 1, then here it is 1. Next I am passing this fact of j comma result 1. This j is the input parameter, result 1 is the output parameter. Once you make a function call, then the procedure will be here this function call, this called function will be invoked. So then it will returns the value. Again, I'm calling this factorial function by passing I minus j. This is n minus r. So this is nth term, this is r term, this is n minus r terms. So I minus j is the input parameter, res2 is the output parameters. So once you have evaluated this n factorial, r factorial, n minus r factorial, then that value will be stored in the variables res1, res2. So based on this BODMAS rule, you need to evaluate this value, then the results will be stored in the variable result. Then you need to print the result value, then you need to increment the j value. J is incremented by 1, j becomes to j plus 1. So inner for loop will be repeated for each value in the particular row. Next, by incrementing this I value, it will goes to the next row. Next, if possible, you need to try to optimize. These are the feasible solutions. In the last video, we have discussed Pascal triangle using formula based. In this video, we have discussed Pascal triangle using functions based. So in this way, you can solve the given problem in n ways. So all possible solutions are feasible solutions. So then you need to find out the best solutions. Optimal Pascal triangle using various algorithmic strategies like dynamic programming and other strategies you can try.